I have shared the live editor window. So the very first example, what we are going to see in high frequency analysis is how to design a high frequency band pass filter. Okay, so this comes as a part of your maybe in a UG syllabus you would have studied about transmission lines and waveguides. In that you would be studying about the design of filters using lumped elements and distributed elements. So here we are going to see how we are going to create or design a band pass filter in a high frequency for a high frequency application using inductor and capacitor. Same thing you could have done using PSpice. You would have dragged and dropped the components and you can do that. But MATLAB has been added with a feature. We have added the RF toolbox in MATLAB. So by using those RF toolbox objects, even the same thing can be done in MATLAB in a very simpler way. So you can see here theory portion. So we are going to design band pass filter. So you know band pass filter is a filter which is going to allow only a particular band of frequencies. That is going to be the pass band. And outside the pass band, the filter is going to reject all the particular frequencies. So it is used mainly in frequency selective applications. Mainly, if you want even more in detail, I can say an example of an FM receiver. You know, an FM receiver can receive all the FM station signals. But when you are tuned to a particular frequency, it can filter out that particular frequency alone. Correct? So that application can be thought of for this band pass filter. So it is going to allow a particular band of frequency and it is going to reject the remaining band of frequencies. Okay. So we are going to use, see here, I'm going to use capacitor and inductor only for designing this band pass filter. So we'll see, this is the structure. See, whenever inductor comes in series and a capacitor comes in shunt, that is going to be a low pass filter, correct? Because you know, at low frequency, the inductor becomes short and capacitor becomes open. So whatever you transmit will be sent to the receiver. When you have a capacitor in series and inductor in shunt, that is going to be a high pass filter. Because at high frequency, capacitor will be short, this inductor will be open. So band pass filter is nothing but combination of high pass filter and low pass filter. So you will have an LC series and you will have an LC shunt. This is going to be, there is no separate circuit for band pass filter as you all know. We are going to cascade the circuits for low pass filter, which is L and L series C in shunt, and high pass filter with the C series and L in shunt. When you cascade that, it becomes a band pass filter. So you have LS1, CS1, LC series combination, LP1, CP1, LC parallel combinations. Similarly, you can have one more set of LP2, CP2 parallel and LS2, CS2 series combination. So I'm going to use two sets of band pass filters to achieve the filtering operation. And this question is taken from this book, Complete Wireless Design by Carter W. Sayre, Tata McLaughlin edition, 2008, page 331. So we are going to take this circuit from that book and we are going to design the band pass filter and we are going to see how the band pass filter is exactly fitting into my